morning, everyone. Thank you for joining me. Lee Zaretsky. I'm with the client office of the CTO at Dell, working on, among other things, the NVMe storage. No surprise there. So I'm going to be talking a little bit today about where we are in our transition away from slow mechanical clunky devices to solid state and basically NVMe-based solid state storage. And then I'll be passing off to my colleagues from Intel. We'll be talking more about workloads and workload analysis. So I want to touch on a few things here. Really our broad strategic vision and why we're going through this transition and the impacts of that to our products, and specifically addressing what our customers ask for and why that's a part of this transition process. So I'll talk a bit about how we classify SSDs within our product space, talk about form factors, because that's a critical part. Certainly we'll touch on the next generation of PCI Express, which of course is influential in where these SSDs are going. And I want to summarize at the end with our objectives and where we think this is going to lead us as we look down the road. And I did throw in that epilogue. Even though hard drives are not related to NVMe storage, it's relevant to touch on it at the very end to show where they will potentially continue to live in our scope and space. So from a vision standpoint, when we first began this transition in our product set, and we talked to our strategic partners and to customers, there was generally surprise when we said, hey, you know, we're migrating away from mechanical storage devices to solid state. And the reason for the surprise really is if you think about client workloads, most of them are not very stressful on the storage subsystem from a performance standpoint. And so there was a lot of surprise of why would you go there? Why would you take that kind of a change in the portfolio? Well, what I try and explain whenever I have that conversation is that solid state storage is more of an enabler of other features and not just the performance of the storage subsystem. It allows us to get away from a critical physical roadblock, which is the 2.5-inch form factor that we're tied to with mechanical devices, and migrate to our form factor of choice, which is M.2. And that allows us in turn to make products that are thinner, lighter, more mobile, that run all day. And even when we're talking about fixed desktops in an office space or in a home office, we're talking about smaller physical footprints, right? Customers are looking for near zero footprint on their desktop with that desktop product. You know, products that strap under the desk or mount on the wall or mount behind a monitor. That smaller form factor is becoming key in all the products that we see. And yet, as we go there, customers don't want to lose performance. They don't want to lose capability. A quick aside, I don't know if you remember a number of years ago when we introduced things called a netbook. Netbook was small, thin, and light, but the performance was horrible. And so they failed because they lost sight of what mattered. We needed a better footprint, we needed a more mobile system, we needed a smaller desktop, but we couldn't give up the feature set. In fact, we wanted more performance. We wanted more capacity as we sized down the product set. So what we hear from when we talk to customers and partners is what you see on the slide here today. We care about responsiveness. Performance translates to how responsive that system is in a client workload. And we talk about smaller, thinner, lighter, more mobile. And we talk about system runs all day. Now that's clearly a mobility statement where the batteries are involved, but our ability to put cost-effective and performance-effective storage into a much smaller footprint, like M.2 or even BGA, and we'll talk about that, allows us more space within the system to put battery cells, to put other storage devices, to put more comms, other I/O capabilities. So storage is not just about performance. Solid-state storage is also about an enabler for other features in the box. So I wanted to briefly touch on some of the macro-level trends that are driving us in the direction that we're going, and then we'll get to a little bit of a conversation around how we classify the performance that we see and then the form factors that are relevant for client products with storage. So mobility, I've already used that word probably 3 or 4 or 5 times on the early slide. Mobility matters, right? Our customers care about taking their compute units wherever they work, whenever they work, however they work. So it might be, something as small as a smartphone. It might be a thin and light laptop. It may be some other kinds of device. It's important that customers are able to work as they need to, and that drives that thinner, lighter, more highly mobile product. Remote storage is certainly worth talking about. We're seeing a lot more of our customers and partners push what used to be a mandatory part of their local storage out to the cloud. And as we see a more pervasive connections materializing in client products, and as we see a greater trust and reliability and security in the cloud, I think what we're going to begin to see is some of the storage that has been a fundamental part of that endpoint, that client system, will start to migrate away from the client system, allowing those to be smaller and lighter weight and push some of that storage requirements out into to the edge and beyond that to the cloud. Massive content, we have a lot of client-centric workloads that are driving content creation, that are driving numeric processing, that are driving a number of other features that deal with massive amounts of data. That has driven a need for greater capacities even as we try and shrink the box to something smaller. So that's another factor that's been driving how we consider the appropriate form factor and capability of our storage solutions. And finally, and this is a little bit of an opposing vector here, we have professionals and pro-consumers who demand a lot of local capabilities because of the needs of what they do. So if I think about gamers who have a lot of I'll say game scenery and other data locally. If I think of specialized workloads like oil and gas industry or finance with high frequency traders, medical research, scientific research, a lot of those applications are driving the need for keeping more and more data local. So even within what I've talked about here on this slide, we see kind of a dichotomy of some workloads and some systems that really want the data to move away and be in some area that can be shared and easily accessed as they move between devices, and others want to keep that data much closer to the compute node to make sure it's readily accessible and can be processed as it's needed. Let me move forward here. So to help our customers in trying to assess their storage needs, we've gone a step beyond the normal parameters, which are usually what's the density of the storage solution and what's the cost. And so certainly those are key parameters when they're sizing their systems. But beyond that, we wanted to give them an easy way to assess how the performance of that storage solution matched with their particular workloads, right? As I said, many client workloads are not very demanding on the storage subsystem, but there are others in our extreme gaming products, in our workstation products, where there is a consistent use and a high, I'll say a high strain on the storage subsystem. So we classed it into three classes, and I'll start from the bottom and work my way up here. Value is the class of product where the customer cares about the form factor and good enough capacity, but really is centered on cost. They want the best cost they can get per bit. They want a good feature set, and performance is really not at the top of their list. And so for that, NVMe-based solutions have offered us the ability to get that scalable solution all the way down to a more cost-effective media that still meets all the needs of capacity and the performances that the client solutions will demand. Above that, we have a mainstream class, and this is kind of the sweet spot in our portfolio, right? These are the volume products that have a good balance between performance, cost, and usability at the right capacity points. And so for these types of products, NVMe offers us the ability to scale up. It gives selection and choice to customers who want to plan their products accordingly, especially in the commercial world where they're buying a variety of different products across their organization. And it also gives us the ability to deliver a burst performance when needed for the workloads that have those kind of bursty type of use of data. And then finally, we have our performance class. And performance class is all about sustained performance. So these are the larger capacities, the best performance, and often they will be the more expensive solutions that we'll deliver to our customers. But these are for customers who really demand that kind of performance and capability. Again, usually extreme gaming, workstations, other high-end client applications. So I talked a lot about form factors already. There's numerous form factors out there, more than what's shown on this page. And certainly we're seeing a lot of churn in the enterprise as well on a proliferation of form factors. And I believe there was an announcement even from our friends in Toshiba yesterday about a new form factor in a dense, I'll say client or scalable node application. What we're looking at Dell for the client portfolio is centered primarily on M.2. And to balance out flexibility for our customers around performance and cost and capacity, and also to maintain the least amount of complexity in our portfolio, we've decided to center around the 2280, the 80 millimeter M.2, and the 2230, 30 millimeter long M.2. It gives us a good choice around cost, capacity, performance, and a flexible set of solutions without overwhelming ourselves and our customers with too many selections, too many choices. We do have some targeted solutions around BGA. We've shipped a couple systems already with a 16 by 20 BGA, which were systems that were very demanding on physical real estate within the design. And the BGA was just a better fit there. At the end of the day, our customers are not coming to us and saying, gee, I really want that BGA instead of that M.2. What they're asking for is scalability, performance, cost, and the ability to meet their workloads effectively. And so that's why we have a diversity of products that offer a selection for them, and we help them achieve their goals. So obviously, the next generation of PCIe is here, and PCIe offers the performance boost and capabilities that we'll certainly use in some spaces. But again, does PCIe 4.0 matter across all our products? Actually, it doesn't. But what we do want to achieve over time as we get into the next decade is to standardize on this as the framework that we'll use across all our products, both desktop and mobile, for solid-state storage. It gives us flexibility. It gives us the ability to size the storage solution for the customer, and ultimately for products that don't demand the kind of bandwidth that 4.0 can deliver, we'll have the ability to scale back and run it slower. So I do want to touch on this quickly as I'm reminded that my time is short. There's been a lot of conversations about QLC. QLC will land as a opportunistic solution within our portfolio. And I say it that way because TLC will continue to be the lion's share of solid-state storage that we deliver over time. So a couple points I want to make that you should take away from this slide for client products. As we move forward in time, SSD begin to become the predominant factor in our portfolio. Today, we've already crossed over SSDs and hard drives in what we ship in our mobility space. Desktops are lagging a little bit behind because they do typically have larger boxes and can support that 2.5 and even the 3.5 inch form factors. But we're going to see SSD and specifically NVMe based solutions to be the predominant solution going forward. You'll notice the reference in value as I look farther out to the right between TLC and QLC. Jury's still out for us on where QLC is going to land. We think it'll have a good sweet spot somewhere in our consumer space. We think there'll be opportunities for it, but the balance point between cost, performance, and capability is still not clear to us. So we're watching to see where that's going to land. So let me summarize here. We talked about a diversity of products that we need to address. NVMe helps us address that accordingly. Responsiveness matters. We care about how the system responds to the particular workloads and needs of the customer. All right? We talked about performance, physical size, and power efficiency or runtime as being key criteria to help measure the value of NVMe-based solutions for us. And we know that there's a number of form factors that we'll choose from that help us scale accordingly to the needs of the product. And finally, because that underlying interface and technology are somewhat agnostic of each other, we know that NVMe-based solutions will help us scale into the future as we look at technologies beyond NAND that will emerge in the next decade. And the last part, the epilogue, the fact is that if we could eliminate hard drives completely, we would do it tomorrow. But the reality is that there is still a space within our portfolio that demands the best cost per bit, irrespective of performance. And right now, that's still hard drives. So we don't expect them to disappear. But as I've stated a number of times already, NVMe solutions are going to be the predominant solution because of the value and the capability that it brings. Thank you. Stop for questions, or we'll hold them at the end?
Let's go at the end.
Okay, great. Thank you. Appreciate it.
So I'd like to apologize both to you and to our third speaker, whom I neglected to mention was going to be joining us as well. We're going to have 3 sections, not 2, so I apologize. But now I'm going to hand it over to Intel, and Romesh and Shiva are going to, well, put it there. We're going to talk about the client platform. Thanks.
So, we have been talking about NVMe, for this whole, sessions, right? And, the storage industry, which was predominantly hard drive, was satisfied with, SATA bandwidth. And, when SSDs were introduced, when flash memories were introduced, it started showing limitations on SATA. And when NVMe was introduced in 2013, it came up with a really wide spectrum of specification, pretty much allowing unlimited queue depths, unlimited number of queues, and stuff like that. So NVMe, was pretty generic, and it kind of spanned across, all segments of computing. We are going to be focusing today on the client segment. We'll talk about, the workload analysis that we have done, and then we are going to talk about, some specific criteria for client SSDs. So we'll talk primarily about, the key storage requirements for client platforms. For most laptops, responsiveness and battery life are the key parameters for optimal user experience. High-end desktop, high-end notebook like gaming systems, they still need high performance and high storage capacities. Most of the storage subsystems, they are generally tuned. NVMe provides a lot of, tunability, in storage. And, storage subsystems are going to be tuned, either for performance or power, depending on their use cases. But most client SSDs that we have in market, they are generally tuned for performance, especially at higher queue depth. When you go buy SSDs, and you look at the performance, you look for, sequential reads, sequential writes, queue depth of 32, queue depth of 64. With increasing adoption of SSDs in laptops, does it really, is that the right choice? Is higher queue depth really important factor for real life workload? We have done, extensive study of all the different workloads in client environment. We looked at several synthetic workloads as well as, synthetic benchmarks, as well as some real life traces, in client usages. And we are going to share some of the data that we have collected today. I'm going to invite my colleague here to present his data.
Good morning, everyone. I'm Shivashekar Muralishankar. I work as a systems engineer at Intel in the NAND Solutions group. So the first benchmark or the workload that we would be talking today would be PC Mark 8. So PC Mark 8 is a common storage benchmark that emulates some of the very common user applications such as Creative, Adobe Suite, some of the Microsoft applications, and also some of the popular gaming workloads. So based upon the analysis that we have done on this workload, I would want to go share our learnings. So if you look at this graph, this graph represents a spread of read-write operations over various queue depths. So the x-axis here is number of pending requests, and the y-axis is the frequency of the read-write distributions throughout the workload. And the orange bar here represents the write operations. The blue bar represents the read operations. And PC Mark 8 is pretty much a mixed workload with both of these write and read operations, predominantly a random one, pretty much. And the graph evidently proves here that most of the read-write operations are segregated in and around lower queue depth. So it's dominated by queue depth 1 to 6, which is like 80% of the read-write operations are under queue depth 6, which will contribute to a very good score on the benchmark. The next benchmark which we evaluated was MM14, or it's also called Mobile Mark 14. MM14 is an industry standard benchmark which is normally used to measure the battery life of a given mobile platform. Also, it is a workload, it's an app-based workload which kind of uses real data sets to measure the performance of the system too. And here, again, the read-write ratios are distributed here pretty much among all the lower queue depths. If you see, it's distributed all the way from 1 to 8. And again, the majority domination is queue depth 1, which is like more than 80%. And the next one which we want to focus here are some of the real-life client workloads. So it's called Hobble, which stands for hours of battery life. So this was a standard which Intel and Microsoft came up with for evaluating the client platform for a better user experience. And we did concentrate on some of the very key scenarios that users pretty much run in their daily life. So if you see, you have something called web browsing, video streaming, the local video playback, and also the productivity. Productivity all contains all these Microsoft applications like Excel, PowerPoint, and everything. And all these real-life client workloads are also typically dominated by QD1. So that key takeaway is, at least even in real world scenario also, you are running into the situations where the host application is kind of passing queue depth 1 here. And
So I think just kind of summarize, what we showed, right? I mean, all the analysis, again, we just showed, a few of the workloads here, but, we have done extensive study and we keep studying, as new and new benchmarks, evolves, and we keep collecting more user traces for different use cases like consumer and client and things like that. And we see that all the workloads that we have is heavily dominated at lower queue depths. We barely see, some I/O transactions that are happening with queue depth of 8 and higher, and rarely see anything that is higher than queue depth of 16. So, in conclusion, what is important for client? The responsiveness is very important. That means, the lower queue depth performance is very important for optimal user experience, right? And of course, battery life is important. Most of the evaluation that we see and the spec that we see when we look at client SSDs are all focused on like QDEP 32 performance, and there are a lot of synthetic benchmarks that are focusing primarily on like QDEP 32. They give some data on QDEP 1, but generally that is not really looked at. Mostly people focuses on sequential reads and writes at higher QDEP. So I think as the industry is changing, as there is more and more adoption of SSDs in laptop segments, I think we need to make sure that our benchmarks and our focus is getting more towards lower queue depth and faster responsiveness.